There are a couple of important words to understand the meaning of in this unit, and here they are: position, origin, speed, velocity, scalar, vector, distance and displacement. And so in this video, I'm going to be showing you what they mean. So by this point, we've looked at equations like this: x equals 10t plus 5. And we know that this equation can be used to find, literally, the position of an object. But what do we mean by that? For example, let's say we want to find the position of the object at 2 seconds. So we'll put in a 2 for t. 2 times 10 is 20, plus 5 equals 25 meters. But what does 25 meters actually mean? 25 meters from where? Well, the answer is 25 meters from the 0 point on a number line. So if we draw a number line, and we draw 0, and maybe we have 5, 10, 15, 20, 25, so this is in meters. What this is saying is that at 2 objects, the object is at this location. It's 25 meters from 0. Now, what does 0 actually represent? It could be anything. It's arbitrary. 0 could be anything in any given problem. It's not particularly important, but 25 meters simply means that you are 25 meters from whatever you decided 0 would be. So that's a couple definitions right there. So the word origin does not mean where the object started. Origin means where the number line starts. So the origin is the location of 0 on the number line. Again, it doesn't necessarily mean where the object started. It just means where 0 is on your number line. Position is just the location of an object on a number line. So to say that an object's position is 25 means that it's at position 25 on this number line right here. Nothing more complicated than that. So we've also learned at this point that the number 10, for example, in this equation represents how fast the object is going. And there are 2 words that can be used to describe how fast something is going. One of those words is speed, and the other word is velocity. And in this class, it's important to understand the difference between the 2. That technically, the 10 in this equation is known as the velocity. And what velocity is both how fast and in what direction an object is moving. And whereas speed is simply how fast. Direction is not included. So speed is how fast an object is moving. And that is regardless of direction. Now, the way that that really gets worked out, the way that you actually see that, is if we compare the equation that I just wrote, which was x equals 10t plus 5. What if I wrote this equation, x equals negative 10t plus 5? Well, if you think about where these 2 objects would be 2 seconds later, this object, as we already saw, would be at 25 meters. However, this object, because of that negative sign, would be at negative 15 meters. So in other words, both objects at 0 seconds started at 5 on the number line. This object ended up 20 meters further in the one direction on the number line at 25 meters. This object ended up 20 meters behind where it started. So this negative sign here indicates to us the direction that the object was going. This object, we say, was going in the positive direction, and this object was going in the negative direction. And so the fact that we can put a positive or a negative here, and it helps us understand which way the object was going, that means that that is technically a velocity. It's not just how fast the object's going, it's how fast and in what direction. In everyday language, if you say, my car was going 25 miles an hour, that's the speed of the car, because you're not saying what direction it was going. But in physics, when we have a situation where the positive or the negative indicates to us which way it's going, that's called velocity. So the basic difference between speed and velocity is that velocity includes direction information. And so that brings up a good point. Two of the other words that I wanted to introduce to you are scalar and vector. And these are two completely different types of measurements. Every measurement in science and in physics can be divided into these categories. It's either a scalar or a vector. A scalar is a measurement that does not include direction. And I'll give you an example of that in a moment. A vector is a measurement that does include a direction. And we just talked about that. Velocity, for example. If we say something has a velocity of negative 10 meters per second, then the negative actually indicates the direction. By the way, the 10 part of this, literally how big the velocity is, in physics we call that the magnitude. That's something you call absolute value in math class, like the absolute value of negative 10 is obviously 10. In physics, if something has a velocity of negative 10 meters per second, the negative part is the direction, whereas the 10, the absolute value, is what we call the magnitude. How big is the velocity? It doesn't matter the direction, how big is it? That's called the magnitude. So literally, by the way, speed is simply the magnitude of velocity. All right, what about a scalar measurement? Classic scalar measurement might be temperature. So if we say that the temperature is positive 25 degrees Fahrenheit, it really doesn't indicate a direction. You can't point your finger in the direction of 25 degrees Fahrenheit. If we say negative 10 degrees Fahrenheit, again, you can't point your finger in the direction of negative. There's a positive and a negative here, but they don't indicate direction. In fact, here's another interesting thing. If you have a temperature of 0 degrees Fahrenheit, does that mean the object has no temperature? No, it doesn't. In a scalar measurement, scalar literally means it's a scale. And 0 degrees Fahrenheit is just a point on the scale. 0 is warmer than negative 10, and 0 is cooler than positive 25. It's really just a scale. Things in the negative part of the scale are smaller than things on the positive part of the scale. But the positive and negative doesn't indicate direction. It just indicates where they are on the scale. In a vector measurement, the positive and the negative, they do indicate direction. So that takes us back to measurements of how far an object has gone. So for example, if we go back to our number line, and so we had 5 meters, 10 meters, 15 meters, maybe 20 meters. And let's take a quick trip, not using the same equation, different equation. Let's say a person starts at 5, they go to 15, and they come around to 10, and that's where they stop. Well, if you ask the question, how far did that person go, you could get two different answers. So one answer would be the distance that they traveled. And that is the length of the actual pathway. Here, that would be they went from 5 to 15, so that's 10 right there. And then they went from 15 back to 10, so that's another 5. So the length of the actual pathway that they took was 10 plus 5. The answer for distance traveled here would be 15 meters. But it would be really hard to say the direction of that because they curved around. I mean, they went this way part of the time and they went that way the other part of the time. So distance traveled is a scalar, and it's the length of the actual pathway. Now, another thing you could say that would have meaning is, well, they started here and they ended up there. So they really only, overall, went 5 meters. And you can also say that they went 5 meters to the right. So you could say they went positive 5 meters. So when you talk about how far something went that way, that's called displacement. And displacement is the length of the straight line from starting point to ending point. And you know what? I should have said the length plus the direction, because it gives you the direction as well. In this case, it was positive 5. To convince yourself of that, imagine a person who started at 15 meters, went to 20, and then ended up at 5. If you look at the starting point versus the ending point and draw a straight line, they started here, they ended there, they went to the left. And by the way, literally, there's a formula for displacement. I should mention that. It's delta x. You simply take final x position minus original x position. Just subtract final position minus initial position. So when you take a final position right here of 5 meters minus an initial position right here of 15 meters, you get an answer of negative 10 meters. Do you see how that calculation automatically gives us the direction as well? It automatically tells us that it's negative, which would be to the left. So one last thing, while we're talking about these terms, let me just go back to the idea of speed and velocity, and I want to give you an equation for average speed and an equation for average velocity. So average speed is distance traveled, remember that's not a vector, divided by elapsed time. And average velocity is displacement, which is a vector, divided by elapsed time. So again, this is another reason why speed is not a vector, because it's based on distance traveled, which itself is not a vector, whereas velocity is a vector, because it's based on displacement, which itself is a vector. Quick word about symbols here. Distance traveled, probably I'll just write that as a d. Elapsed time we write as delta t. Displacement, as we said earlier, is delta x. There's a formula for it. It's technically xf minus xo, but you can write that as delta x. And again, divided by elapsed time is delta t. As far as the symbols for average speed and average velocity, I apologize that physics could be a little confusing here, but they're both symbolized with the letter v. Basically, that's because in many cases, average speed, or I should say speed, is just the magnitude of velocity. But the symbol that physicists use is that if something is a scalar, then its symbol is a printed letter, so v like that. But if something is a vector, then its symbol is a cursive letter, so a v like that. So this is speed because it's printed, and this is velocity because it's cursive. I know it's a little silly, but that's the way it works. Now, other things you might see is if you write a v with an arrow above it, as long as it has an arrow above it, doesn't matter whether it's printed or cursive. That means it's a vector. That means it's velocity. In a textbook, sometimes you will see it written bold. And again, bold means that it's a vector. If it's not written bold, then it's a scalar. So I know some of these things seem a little silly and a little hard to absorb, but that's part of the job. So good luck with that.